Hello guys, this is Mr. Lopez, and in this video I'm going to go over the first review of the year for y'all's test, which is coming up this Monday. So I'm going to go ahead and get started to keep this video short. Alright, so number one, you have to tell a story and you have to look at the information that you have, and they're usually going to give you one out of the four boxes. So in this case, they give us the algebraic and sum of the table. So we can use these two, kind of like play a puzzle, and then we're going to fill in the rest. Now, when I did this in class, I did some of it a little bit incorrect, not the math. So if you understood what I talked about, you're good. It was just a very minor thing, but I'll do it correctly here. It's not going to affect your knowledge or anything like that. Okay, so first thing I'm going to do is I look at the equation. I'm going to start with this here in just a little bit, but before I do, I'm going to look over here. So they tell us that every 2 hours, or they give us the hours, they give us 2 hours, 6 hours, -3, 0, and the first column represents your X, the second column represents your Y. Y represents sodas, X is going to represent time. So let's break down the equation over here. The B term over to the right, this over here will usually or always represent how much you start off with. It doesn't matter what the story is, it's what you begin with, your initial amount. In this case here, this represents sodas. You have 6 sodas to begin with. On the left, this represents your rate. That's going to tell you how fast or how slow it's increasing or decreasing. The bottom number will always or typically represent time. In this case, it represents hours. Let me not write that as a fraction, but so in this case, it represents hours. The top number of the fraction, the 1/3 up here, that will represent the same item, whatever it is you're talking about. We're talking about sodas, so this means 1 soda. These two will always match, whatever it is. If this is cakes, this is 1 cake. If this is 6 chips, that represents 1 chip. That's what that represents. So if I also tell a story, you can always use this template to help you write the story. I start with 6 soda cans, right? Because that's what you begin with. So I start with 6 soda cans. And then on the next sentence, you're just going to tell me how fast or how slow you're drinking it. Now this one is decreasing, right? Because it's a negative. So on this one, you're drinking or you're throwing it away or whatever the case is, right? You're going to say, and I drink 1 soda can per hour. And that's how you tell the story. So always break down the fraction like this. Now, to fill in the table, you have a couple of options. You can take each of these are your X's, and plug them in here and just calculate it. And then because this is your Y, you would put this in place of Y, and then you can solve it. But you can also use Desmos. So I already have this graphed on Desmos. So let me go ahead and pop this up. Let me bring this over here. Actually, let's make the Desmos bigger. All right. So let's pop this up. Let's see, where is it? Here it is. Okay. So I already have it graphed. If you want to pop up the table, then what you want to do is you're going to hit the settings wheel, then hit the table, and there you can pull up the values, right? If I need the number 6, which we do, you can just put 6. I think, what else did we need on this one? It was asking for -3, right? So you can just type in, you can just do -3, boom, there's your answers. So we can fill in some of this table already. 6 is 4, -3 is 7, and then 2, we can just put 5.333, always round to 3 decimal places. And then you can obviously sketch the graph. It looks like it crosses at 6, so we can just go 1, 2, 3, 4, 5, 6. And then it looks like we have a point at, what point is that right there? 3, it looks like it's 3, 5. So 1, 2, 3, 1, 2, 3, 4, 5. And that's enough for a straight line, right? So we can go like that, and then there's your straight line. Now, for 0, how do you get that 0? Well, this means that y is 0. So what you can do is just look for 0 on the y-axis, which would be over here. You click right there, and there it is. So that would be 18. So that means that in 18 hours, you will finish all your soda cans. That's a lot of sodas in 18 hours. Okay, so let's go ahead and let's go back to the review, and we finished number 1. Cool. All right, so there's number 1. Let's go ahead and move on. Let's go to part 2. All right, so on part 2, you are basically just going over function notation and being able to take a function given x or given y or given whatever input and just knowing how to mess with those. So always identify which function you're using. At the top, you have 3 functions. They're named by letters, right? So we have function f, function g, function h. Your job is to look at all 3 of these functions and just kind of use the correct function by name. So on the first one, we're using function f. So we're going to use the first one. So on this one here, we're just going to go ahead and plug in. This is your x. This is your input. That means that wherever you see an x, you're going to put a -4. So I'm going to take the first function. That's going to be 3. In place of x, I put -4 squared 2 parentheses -4 minus 1. Now, this technically is the correct answer because you've shown me you know how to plug this in. You can stop right here and receive 4 credit, or you can type this into Desmos and that'll give you the answer. I did not pre-fill the Desmos to show you what the answer is, but if you watch the video, it goes over what the answers are. I'm going to go ahead and stop right here. If you were to solve this on Desmos, I think it's like negative. I'm not even going to, I don't remember. I'm not even going to do it because I want to keep this video short. Let's go to the next one. So this one is different. They don't give us the x. The 20 represents the y, or in this case, it replaces your g of x. So we're going to, instead of placing the 20 in for x, the 20 is your g of x. It's kind of like your y. So we set it equal to that function. So it's going to be 20 equals 9 minus 2/3 x. Now this one we do have to do a little bit of solving, right? We're going to have to get x by itself. So I'm going to minus 9 from the 20. So how do we get rid of the -2/3? You have 2 options. When I did this in class, for some of y'all, you could just simply divide this number into 11. You do the opposite operation, right? Because you're multiplying it here. So you would just do 11 divided by -2/3, and that'll give you the answer. There's another way to do it. I didn't do this in class, but another option would be, you do the one that works for you. You can multiply by the reciprocal. So if I multiply by -3/2 on both sides, it's the same thing as dividing it on both sides. I just prefer this method. I put it over 1, the 11, and then just multiply across. So -3 times 11, that's going to be -33. 2 times 1, it's going to give you 2. And that's my x value. That is completely correct. If you gave me the decimal, which would be -16.5, both of those are correct. I prefer fractions, but decimals are fine as well. C is just like A. So I'll do this one quickly. We're going to plug it into h of x. So we're going to take 4, plug in 5 in place of x. So we put a parentheses. And again, technically, you can stop here. This is the correct answer. Now, if you are going to type this into Desmos, I do want to show you that here real quick. Let's do a new one. Okay. If you're going to type this into Desmos, you got to do it like this. So you got to do 4 plus 2. And put the thing up there. Let's come up here. You have to put parentheses right here because if you don't, it's going to drop down to 3. So I'm going to do 5 plus 3, close parentheses. That's the correct answer. So be careful how you type it in. So we would say then that, let me get rid of the Desmos. There we go. So then that means that h of 5 is equal to 260. And you're done. That's the correct answer. Okay, now the next one, D. Now, I did tell regulars you don't have to do deep. It's actually really easy. I may leave it on there for extra credit for regulars. So if you want to watch this, go for it. Advanced, you are responsible for knowing how to do this one. So this one we're going to pull the f of x. This one we're just going to plug it into x. So we're going to do 3. We're going to plug in x plus 2 in place of x. Then we do 2, and this would be x plus 2 minus 1. And this is equal to, let me move this actually. Just a little bit. There we go. Let me erase this on this side so I can use that. Then we would say f at x plus 2 is equal to, and you can stop here. That's the correct answer. You're done. Now on this here, for you to get full credit, you do have to share. You have to write this part. You have to say f of x plus 2 is equal to this if you're not going to simplify. Now, if you simplify, that's fine. But just make sure you do it correctly. Same thing up here. If you're just going to leave it like this, make sure you put h of 5, or I'll take off a point for that. You have, if you're not going to evaluate it, you have to show it like that. Okay, so let's move on to the next part. I did tell everybody in class, I think I did, we're going to start with number 3, but we're going to put number 3 in point slope. We're not going to put it in slope intercept, because in class, that's how we did it. I will give you all the forms for the test. You don't have to memorize anything. So number 3, I want you to read it real quick. If you need to pause it, go ahead and do so. But we're going to go ahead and solve it. So we're looking for the equation that's perpendicular to this one. So, and we want to put it in point slope. So they give us a point, and it goes through this point. And so what we do is we're going to write down point slope, which again, you don't have to memorize this. I will give it to you the day of the test. The 50 represents the negative 50 is your x sub 1, the 10 is your y sub 1. So what we're going to do is you're going to replace 3 things on here. You're going to replace the y sub 1. We need to figure out the slope. And then we need to replace the x sub 1. Everything else stays. So we already know y sub 1 and x sub 1. We just need to know the slope. Now remember that the line perpendicular to this line, the slope is going to be the negative reciprocal. So we have to change the sign and flip it. So I'm going to write 4 over 1. That way it'll make it easier for me to flip it. So the slope that we're going to use is going to be negative 1 over 4. Now we have everything we need. Now we're going to write it. So we're going to do y sub 1, which is going to, or y minus the y sub 1, which is going to be 10. We now know the slope is negative 1/4, parentheses. My x is negative, so I make it positive, and there it is. That's your answer. So if you understand this, go ahead and move, fast forward. What I'm going to do is I'm going to show you on Desmos, though, that these are perpendicular. So I'm going to go ahead and graph this and this. I should have had this graphed already, but I didn't. So let's go ahead and do this real quick. So let me graph y equals, and then let's do y minus 10 equals negative 1 divided by 4, parentheses, x plus 50. Let's go ahead and zoom out a little bit. And voila, they make a 90-degree angle. Perfect. Okay, so let's go back to this real quick. So standard form. Now, I'm not locking your, in other words, you can use Desmos on the test. So, I mean, I know you can just graph that and boom, that gives you the answer. But this is easy to graph, probably easier to graph without Desmos. So you're going to do the cover method. So you're just going to get the x and y intercepts. So the easy thing to do is just do x and y intercepts. So what you do is with your finger or your pencil, cover this right here. Don't look at this. So if we let x equal 0, just cover it. You're just going to solve this side over here for your y-intercept. So 20 divided by negative 5, it's going to be negative 4. So your y-intercept is going to occur at negative 4. Your x-intercept, you cover the negative 5y. So you do 20 divided by 3, that's going to be 6.9. 666, or we'll say about 6.7. And it's going to be positive. So it's going to be about 6.7 because when you do 20 divided by 3, you get about 6.7. And there you go. So you just go to about a -4 on the y-axis. 1, 2, 3, 4. Put a point. And then 6.7. 7, and there's your line. There you go. Done. Boom. Or you could just graph it on Desmos, right? We've already talked about point slope. So we're going to put it in this form. But on this one, you need your slope. So we're going to use the slope formula. So we're going to do y2 minus y1, x2 minus x1. So we have to find the m first. So we plug this in. Remember, this is x sub 1, y sub 1, x sub 2, y sub 2. So let's see, y sub 2 would be negative 93 minus 78 over 36 minus negative 21, but that becomes positive. So our m is going to be, let's see, that would be negative. Wait, did I do negative 93? No, I did that right. Let's see, let's pull up Desmos real quick. Okay, there we go. Where are we? Oh, here we go. So let's do, you know what, let's just do this on a calculator. Guys, it's too early. I don't want to do any math right now. I'm recording this early in the morning. Negative 78. This would be 36 plus, I should have had this ready. So negative 3. So your y is going to be negative 3. I mean, sorry, your slope. So let's go back to this. Let's make this bigger. We got that. Boom, done. So you're done. So now we're just going to plug everything. As before, we're only going to replace those 3 things, right? So this is going to pick any point. You can pick the first point or you can pick the second point. I'm just going to use the first point. So it's going to be y minus 78 equals negative 3, x plus 21. Had you used the second point, you would have got the same answer. It looks different, but it's the same thing. Okay, number 4. This is going to be where you're going to have to solve by factoring. So the first 2 have to be done by hand, which means you have to show work. The third one, by graphing, you don't have to show any work. You just graph it on Desmos. Okay, so the first one. Always look for your GCF, right? So if I look at this problem here, this has a GCF. 3 divides into both numbers. So our GCF is going to be 3. And you can also take out 1x from each term. So that's our GCF. So we're going to pull that out. So that's going to go out in front. And then we divide each one by 3, which is going to give us x. And we remove 1x because we took one away. 27 divided by 3 is going to give you 9. We took away the x, so this is equal to 0. Now this one has 2 factors. Actually, nope, I lied. Well, yes, kind of. This can still be factored. We can use the difference of squares. So then this would be 3x. And then this would be x plus 3, x minus 3 equals 0. We now have 3 factors. And we're going to set each factor equal to 0. Okay, so we do 3x equals 0, we do x plus 3 equals 0, and then we do x minus 3 equals 0. The first one, you divide by 3. Well, 0 divided by 3 is just 0, so the first one is 0. The second one, we subtract 3, so x is equal to negative 3. And then finally, we add 3 on the last one. X is equal to 3. Now, you don't have to show what's here in sky blue, the work, but I just wanted to show you where the answers come from. And there you go. You box your answers. You are done. You must show work on these. I will not accept your answer if you did not show work. Number 2. Now, we know we have to do this by hand, but this one is not ready to solve. What we want to do is we want to move everything over to one side. Always check to make sure that your x squared is positive, which it is. So what we're going to do is we're going to move the two terms on the left. We're going to go ahead and move those to the right. So we want to move everything over to one side and set it equal to 0. So let's go ahead and start. So we're going to do the opposite operation. So we're going to do plus 9x. We're going to subtract 5. And we're going to add those over here to the left. Go ahead and draw a line if it makes it easier for you. What ends up happening on the right, they're going to cancel, which is what we wanted. And we're going to get equals 0. Go ahead and bring everything down. Now, I am going to move the 2x squared to the front because that should always go in the front. The x squared goes in the front. Go ahead and bring down your 9x, your minus 5, and now we're ready to factor. So we're going to start with the diamond. So here we go. We're going to go ahead and remember to get the top part, you do a times c. So we're going to do 2 times negative 5, which is going to give you negative 10. Then on the bottom, we just put the b term, so we're going to put the 9. So this goes here. So remember, the top is always going to be a times c. The bottom is just your b term. And then as always, your puzzle, you're thinking of two numbers that multiply to give you negative 10, but add up to give you 9. Now, let's say that even though this one's pretty easy, some of you still struggle a little bit, which is okay. There's nothing wrong with that. Some students struggle with negatives, and I have a trick that I use sometimes because I have a tough time figuring out what these two numbers are. So I have a student that I had about 3 years ago, Sam Robbins. He's in my calculus class. He showed the class this trick, which I've been using it for 3 years, and students love this trick because it helps them when they can't figure out what these two numbers are. So let's go ahead and bring in our diamond. our Desmos. And I'm going to pull up, I already have it saved. It's called the I have it called as the Sam Robbins method. So what you do is you're going to type in x, y equals, and then whatever number you have on top of the diamond, you're going to type that into Desmos. So you're going to put a negative 10 right there. And then x plus y, you put the bottom number of the diamond. So this will help you whenever you're stuck. You're like, man, I can't find these numbers. What you're going to do is you're going to click where these two graphs intersect. So I'm going to click right there. You see that it's negative 1 and 10. So we come over here, negative 1 and 10. Boom. Your diamond complete. So use that when you get stuck, right? It's a nice little trick. All right, so we have our diamond. So once you have your diamond, we want to divide these by 2. Reduce the one, or reduce to fractions if you can. This one's reduced, this one is not. So this one reduces to 5 over 1. So now we're ready to write our factors. You start from the bottom of the fraction and work your way to the top. Bottom, work your way to the top. So the first factor is going to be 2x minus 1. The second factor is going to be x plus 5, and I equals 0. And I just got these from here, right? 2x minus 1, x plus 5. Now you set each factor equal to 0. So we do 2x minus 1 equals 0. X plus 5 is equal to 0. We know that this one is just x equals negative 5. And then on the left, we have to do a little bit of algebra. You plus 1, boom. 2x equals 1, divide by 2. So you get x is equal to 1/2. Those are your solutions. And you're done. All right, the last one. This one I like because you just use Desmos. So let's go ahead and again bring in our graphing calculator. All you have to do is just graph it, right? So you're just going to type in x squared plus 9x equals 32. Now, what you're looking for here are your x-intercepts, right? Because since we're looking for our x equals, you're just looking for that. As always, round 3 decimal places. So your solutions are x equals negative 11.728, and then x equals 2.728. And there you go. Those are your solutions. Boom, done. Easy. Move on. Okay, now the bottom. So I've already graphed this on Desmos, so we'll have it ready and stuff and so on. Pause the video if you need to read it real quick, and then I will go over it. Okay, couple of things here. Ignore this stuff here. Don't don't worry about the calculator. That's not important. We're gonna skip this here. We'll do that later. So you've read the problem. So from 1990 to 1996, this represents the total number of radio stations that operated in the country. So your equation is this. Don't get confused. This is your function right here. Oops, let me use the highlighter. This is your function. This is not part of the function. That's just your domain. Your domain is from 0 to t. So you don't need to worry about that part. It's just more about when it comes to the graph. So only what's in yellow, that's what you would graph on Desmos. So I already have it graphed. But before we go to the graph, let's go ahead and answer B. It's asking you, what does this mean? So we need to write a statement. So the name of the function is R. T represents time. R of t represents the number of radio stations. So 0 represents the year 1990. So on this one, if this is R2, that means that it's 2 years later. So correctly, this R of 2 means the number of radio stations in 1992. That's what that means. It doesn't say to solve it, so I'm not going to. But if it did, it wouldn't be hard at all. So let's go ahead and go to Desmos, and I already have this saved, so we're going to make this one big for this problem because we're going to need it. So let me go ahead and pull it up. So here we go. Okay, so here it is. So when you graph it, now notice how I typed it. You can use X if you want, but I typed it in exactly as I saw it on Desmos. So I'd use R of t, so on and so on. When it's asking for R of 2, I can just type in R of 2, and there's your answer. There were about 2,537 radio stations in 1992. I'm just going to abbreviate in case they ask you that on the test. Next is asking, when was there the greatest number of radio stations that operated? Oh, these are country. Or wait. In the country, sorry. So how many radio stations? So basically they're asking for the maximum. So let's go ahead and come to our Desmos. So now, I don't see anything. So if you guys remember, you see the green, you see the 0 to 6. That just means that we're only looking at the window on the x-axis from 0 to 6. But I don't see anything. What's probably happening is that this graph is way up here. But if I go like this, I mean, you can do this if you want. I can see that to the right. I can do this until I get to the top. Or you can zoom out, but then sometimes when you zoom out, oh, actually, I got lucky. Oh man, I got real lucky. So there we go. So there you go. So just you play with it, right? You're just gonna have to mess with it. Be gentle. Some of you zoom out too crazy, too fast, and you don't see anything. Let me go ahead and get the answer on this one. So the maximum obviously is going to be right about there. So about 2,617 radio stations. I rounded down because you cannot have, part of a radio station. So 2,617. So that would be the answer. So we can write that in. What is it? 2617. Now, when you write your answer, make sure you don't just put the number. Write down 2,617 radio stations. Make sure you tell me what the number represents. And we're done. Easy. All right, one more and we've made it to the end. Now, this is a regression problem. Do not worry about this part here. That's not going to be on the test. Let me drink some coffee. Okay, so we have a word problem here. And Mr. Bean thinks it's a linear model. So regardless, so we don't know if this is, when you take the test, you need to go in not knowing if it's linear or quadratic. You need to figure it out. So we're going to see if Mr. Bean is right or wrong. And so when you do this on Desmos, you're going to enter the table and you're going to have to check both the linear and the quadratic and see which is a better fit. So what that means is you're going to have to memorize this. So what you're going to have to do is you're going to have to, on Desmos, once you enter it, and I've already have it entered, and I'll pull this up in here just a little bit, you're going to have to do y1 mx1 plus b, and you're going to have to do y1 ax sub 1 squared plus bx sub 1 plus c. You have to test both of those. I can give you both of these on the test. You don't have to memorize that. So you have to enter both of those. So let me show you what I mean. Let me go ahead and pull up Desmos. And I've already entered this on the graph. Let's go ahead and maximize this. And let's go ahead and pull it up. And where is it? Oh, here it is. Oh, I thought I didn't save it. So notice how I've already entered it. So I've already entered a table. And notice that I've typed in, you'll see right here, over here, number 2 and 3. Look at lines 2 and 3. We're going to see which is the best fit. I want you to look at the r squared number. The number that the r squared that's closest to 1, that's the one that you want to go with. On this problem, it's not linear. Your r squared is 0.9214, but for the quadratic, it's 100%. It's a 1. We want to use line 3, not line 2. So you can either exit out or just turn it off. We're not going to use line 2. I turned it off. I'm not using that one. I'm using the second one. Now, look at your values. I don't see anything, right? So an easy way to get your window is go here. Look at your x column. It goes from 0 to 10. So just put 0. I like to go a little bit over, so I'm going to do 0 to 12. Look at your y column. It goes from the smallest is 221. The highest is 1821. So I'm just going to do 0 to 2000. There it is. Perfect. Always put your smallest x and y values and you see the graph perfectly. And notice how it captures all the points. If I use the linear, that's not good. It doesn't even hit any of the points. You want the red one. Turn that one off. That's not the one you want. Now you can answer any questions. So let me go ahead and bring in the Desmos. Let's go ahead and put this down at the bottom. Let's put this at the top. Okay. Okay, so now, down here, we are going to answer some questions. So this is not a linear model. So Mr. Bean was wrong. It is a quadratic. It says use a regression and write the equation of your quadratic model. So this is where we're going to use line 3 that's on the computer, on Desmos. So we do y equals. You're going to put it in this form. So standard form looks like this. Y equals ax squared plus bx plus c. You're going to replace the a, the b, and the c with what's given to you from Desmos. So it's y equals, a is negative 16, x squared. Our b, it doesn't have a b term. It's 0. So it's 0x. You typically wouldn't write that, but I'm just showing you. And then your c is 1821. There's the correct equation that models the data that's given. Use the model to predict the height of his glasses at 7 seconds. So that's your x. So you can do one of two things, right? So at 7 seconds, we can just graph, because time is x, we can just do x equals 7. Just go to 7 on here. You can either look for it like this. You can use your finger until you get to 7. Or the easiest thing to do would just be, just do equals sub x equals 7. And where they intersect, so about 1,037 feet in the air. So that would be 1,037 feet. Make sure you put your unit. Find the time at which his glass will be 1,600 feet in the air. Well, 1,600 feet represents your y. So what you do, instead of doing x equals, we'll come back to Desmos, you're going to type in y equals 1,600. And then where that one crosses the graph, right over here, So at about 4 seconds. What does the y-intercept mean? So what this means is how high he was in the tower when he threw the object down, or the object fell off. So that's where how high he was in the air. So the y-intercept represents the initial height, well, we can just call it initial height. And we are done. I believe that concludes, it does conclude the review. That's it. We're done, finally. Cool beans. All right, guys. Again, you'll be able to use Desmos throughout the test. I wish everybody good luck. I will not be able to do a review before the test, so I hope you watch the video. It will be available Monday morning if you want to stop by and ask questions. Good luck to everybody on Monday, and I will see you then.